Well, good morning, everybody. Welcome. I'd like to welcome you to the session to be presented by Cobus Rossouw, CSCP. Many of us know Cobus from his previous leadership roles at SAPEX, where he was chairman of the executive committee and president. Currently, Cobus is the Group Chief Digital Officer of Imperial Logistics, responsible for clarifying how best to extract value from innovation, digitalisation, and technology convergence. If it was possible, I'd ask you to give a big round of applause, but we can't do that. So, Cobus, welcome to the stand.
Thank you, Colin. Thank you very much, and thanks for the opportunity. This is quite an interesting challenge to present. At this stage, I can still sort of see myself, but thanks very much for everybody joining. I think there will be some technical support, but I'll dive right into the presentation if I can get that right. Give me a sec. That should be it. So yes, thank you very much. Thank you, Colin. The title of the discussion today is about unlocking value from digitizing logistics. The first question then would be, well, so what's the definition of logistics? And as I worked through this, I actually ended up saying, well, let's look at some practical transportation examples. I'm going to do my best to apply this to the broader supply chain and even to some of the core other elements around supply chain planning and even manufacturing. But my world is one of transportation, logistics, warehousing. But most of the examples today specifically relate to what we can do in the world of transportation to unlock value, to make things better, but specifically through digitalization. In terms of the areas I would like to focus on today, I'm going to start with service, because that's the reason for being. There's no reason for having logistics if then focus on utilization, because that is by any measure the biggest cost driver. And therefore, for us to be able to unlock cost benefit or cost value, we have to understand the utilization of our assets. Then fuel, which is by any measure the biggest operating cost in transportation. And again, to look at how do we unlock value through fuel. Have to consider the other aspects of life, being people and planet. From there, going to pricing, because all these things relate to cost and the impact of the business, but there's a lot of value to be unlocked by understanding pricing, between cost plus margin being priced. Then I'll reference some digital enablers in a summary to. Let's start with service. First question then is, how do we unlock value from service? Now that must be through revenue. That's pretty obvious. So let's start with the things that are quite easily understandable. The first digital aspect is that we consider conformance to a service level agreement objectively. I would say, but surely that happens. Unfortunately, it doesn't. In the world of logistics and transportation, there are many, many cases where service levels are not measured objectively. They are measured in a fairly ad hoc basis, or they are measured through very analog processes. And the point is, you can have lots of clever control tower technology, but you can only unlock value from service by measuring the service performance objectively if you have a agreed and digitized plan. Now, let's say that I'm starting with the pretty obvious things, but if you don't get this basic step in place, and that is to have a plan for what the logistics activity would be, and then a measurement against that, you cannot digitize the measurement of service, and you cannot measure that at scale. And therefore, you're probably always stuck in only dealing with exceptions. Now, imagine if you had run a factory without having an agreed plan and an agreed actual. The reality is that all production scheduling, all master planning is using the logic of having plans and actuals. In the world of logistics, and specifically in the world of transportation, that's not the obvious case. So in terms of unlocking value from service in the world of logistics and transportation, get the basics right. Then there's some more clever things to do. you could say that communicating an expected time of arrival, or an ETA, is pretty obvious. No, we should do that. We should tell our clients when to expect the load that they are expecting, because that affects the rest of the supply chain. Again, that's not the rule. It's probably the exception. It may be the case nowadays in e-commerce with courier, but lots of transportation activity takes place without having visibility of service performance. Now, we can unlock value from service by just doing that basic right. And the technology is there. We know exactly where all our trucks are. We know exactly what speed they're traveling, where they need to be going. And just to be able to communicate the expected time of arrival will unlock service. Then we can get to some of the more clever digital tool sets. It would be to analyze waiting times and the underlying causes of those waiting times. Now, 3 steps here. If you have lots of data available, why trucks are waiting where they are waiting, and typically that would be queuing for delivery, or they could be waiting for workshop activity, maintenance activity, or they could be waiting in traffic. If we can analyze that, and analyze that at scale, that makes it possible for us to then understand why it happened and then to deal with it. Now, you could again say, but surely this is obvious. It is obvious in warehousing activity, and it's obvious in production activity, that we understand the causes of waste. Now, in the world of transportation logistics, waiting time is the biggest factor of waste. And what digitalization allows us is to actually get the mass data, big data, terabytes of data, and to work through that data by identifying exactly what is happening without somebody having to fill in a form, and to be able to then analyze or diagnose even, and then so be the underlying causes and to communicate them. And then my last point on this first topic of service is just the basic other things about digitizing documentation. That's even more obvious, but again, this is not the rule, and therefore we can, if we start with unlocking value in the world of logistics, some of this is just about. If we move on to utilization, the first point, and I made that earlier, is that utilization has a major impact on cost. To provoke, I've put on the very, very simplistic cost curve of logistics, where you compare the kilometers per year and the cost per kilometer. Now, this is there to provoke the question: is do we truly understand the impact of utilization on cost? Because the curve isn't that simple. It isn't quite as simple to understand that it is just a diminishing cost, because there are impact of shifts and operations. But I would argue that digital allows us, with lots of data available and lots of cost models, to actually start by firstly defining very well, why does cost reduce when we improve utilization? Now, if we know that, we can focus on removing the right type of underutilization or the right type of waste. It would be really travesty if we end up increasing utilization, but because of the specific dynamics of overtime, or shift patterns, or even other governance requirements around travel time, that we end up actually increasing cost, working harder to actually make less money. So we can, first step underutilization is to understand the relationship between cost and utilization. The second one is around measuring utilization and its decomposition. So let me deal with both those concepts. You could again argue that utilization surely is measured objectively. If you just do the quick calculation, if a vehicle is operating for 300,000 kilometers per year, and it's doing it at an average speed of 80 kilometers per hour, it works for the full year. Would you think that would be high utilization? How many vehicles do you know that is traveling 350,000 kilometers at 80 kilometers per hour? That equates to exactly 50% utilization. That is assuming a OEE measure that we've used in factories for a long time. And clearly, trucks don't operate at that level of utilization. They do much less than that. So objectively measuring utilization actually shows you that there is a huge opportunity to remove waste. But then you need to understand the decomposition. And the picture on the right essentially shows an example of how should we look at both the time utilization, so the number of trips, and then the weight utilization, the load, because obviously vehicles are not used all the time in full capacity. And if you apply classical science around how we measure factories, around their utilization, and how we improve utilization through quick turnarounds, you can do exactly the same in the world of transportation. Now, where digitalization comes into this, and again into a world of logistics, which is similar but different, is that we can use all the data at our disposal, all telematics data, as long as you have the data available, which is millions and millions of pings. You can objectively put that through a basic algorithm and determine what time the vehicle has worked, what load it's carried. It's a little bit more tricky because you would need to integrate with other data sources like a TMS, but certainly the speed it was traveling. So again, fairly basic stuff, but understanding the impact of utilization on cost, and then after that, understanding where the waste actually exists, down to the level of understanding what time is required to maintain the vehicle or to debrief the driver, because those are all parts of the logistics value chain or the transportation value chain that you need to understand. And if you use the data to understand that, you can get away from trying to do that in a fairly manual way. Let me say here that everything I'm saying here in terms of unlocking value from digitizing logistics can be done manually, can be done in an analog way. And I should have started with that to say this is about unlocking value at scale. So if you want to do this in faster, better, with more vehicles and more activities, then you need digital tools. The interesting other thing that we've done, and quite successfully, is to map points of interest. Now, again, if you have a relatively small transportation or logistics operation, you will know what your points of interest are. You know the geolocation of your depot, of where you fill up with fuel, of where your clients are. But if you need to do this at scale, you can algorithmically determine what is a point of interest, because you can teach through machine learning, because that's just a fancy word for lots and lots of algorithms, that you can calculate what is what. Because if you realize what's happening in terms of where vehicles are sleeping or they're not moving, or you can link your full data with your transportation telematics data, you can understand what is each point of interest. And then the interesting thing about creating polygons, so you have to actually define a total area that would be a point of interest, because clearly you have lots of little dots on the map that you need to group as one client or one depot or one workshop. And if you've then mapped these points of interest, you can actually quantify the dwelling waste per location type. So you can say how much time is being wasted, so that you can actually populate this decomposition at the top. How much time is being wasted by waiting for a workshop, or for filling up diesel, or waiting in a queue at a client. But you also then need to be clever to eliminate things like waiting at a red robot, because that's not waste, that's the law, that's conformance. So if the more granular you get, the more data you have to eliminate to be able to make sense of what you're seeing around utilization. It's important that we believe that you should visualize moving time, so both waiting time and the time that a vehicle is moving without a load, to enable waste reduction. So visualization of data is important for people to understand what is happening out there. Now again, if we compare this with the concept of manufacturing logistics or supply chain management, the reality is that we can see what is happening in a factory. If you walk into a factory, you can see where there are bottlenecks, you can see where there are breakdowns. The unfortunate reality of logistics, of transportation, is that it happens out there. And what digital tools allows us today is to actually change that, and allows us to see what has happened, not only because we have cameras out there, but actually to visualize what has happened with our assets and with our activities. And the last point, and I think that underutilization is common practice by now, is that you can optimize continuous flow. So that is making sure that a vehicle keeps on working with as little as possible interruption, routing and scheduling algorithms. So those, the ability to understand multi-delivery slots, sequencing, returning to base, those things exist and are getting better by the day. So again, you can make the assets, specifically the physical vehicle assets, work much harder if you go through these steps and deploying the different digital tools that is out there to make it possible. Moving on to fuel. Fuel, as I said earlier, is by far the single biggest operating cost in transportation logistics. And a lot is being done on a consistent basis to be able to manage fuel. The first step is to make sure that you actually understand all the fuel transactions. So you need to know exactly what fuel was filled, where, by whom. You have to be able to link that very actively to your telematics. If you can get those two data sources together in one place, they are able to use that. You can do what we have now, I think, very successfully started and are rolling out, and that is to develop what we call smart consumption baselines. Three groupings of baselines. The baseline essentially says what should the fuel consumption be on a specific segment. So if I talk segment, you might as well think of Strava if you're a cyclist or a runner. But on any segment, you can set a baseline what fuel should be used. Now, unlike just with Strava, understanding that the activity as it is, we have to with vehicles consider also the things that are in Strava, for instance, the gradient. So you need to know if you're going uphill or downhill, but also other things like the load, and ideally also some of the other environmental conditions, road conditions, weather conditions, etc. But the first way to do that is you can actually record it. You can actually go out on your bicycle or with your truck with a certain load on a certain road, and you can go and calculate what is the right fuel consumption that allows you, and this now sounds a bit like standard costing in a factory. Absolutely. If you know what the standard costing is based on the bill of material, and that you need to know how much you need to make a product, we need to know how much fuel we need to make a specific trip. Empirically, you can do that. You can go and record it. It's a good way. You would typically do that on major routes. But the second one, that is to do comparative. We've looked at multiple trips, all digitally. So this is all captured by looking at the actual information coming from fuel transactions and also the utilization system or vehicle management system. And we've seen that, like all things in life, that diesel consumption is not an average. This is a histogram that shows how many of the trips use different levels of fuel. And this is for a standard set of factors. So this is vehicles that carry the same load in the same direction and ideally in the same weather conditions. So this is comparable, but the point is that there are 20% of the loads that actually use less than 36 kilometers or achieved less than 36 kilometers per liter. And if you then look at how do you remove, I'm not sure if you can see my cursor, but how do you actually get these higher utilizations and move them into a lower range? You can actually achieve a saving by either, so it's essentially what this is saying is eliminate the reasons for, or strive towards eliminating the reasons for creating some waste in some instances. Because mathematically, it will always be the case that you have an histogram. So you can create these smart consumption baselines for comparing different trips with the same characteristics. And then you can get even more clever, and that is to use first principle physics. Now, physics here, that is the thing you studied at school and maybe at varsity and thought you'll never use again. If you look at the physics of a vehicle, it means that both its speed and its acceleration is causing a energy consumption, and that energy consumption means that it uses diesel. There are other factors like the gradient, like the load, like the tire pressure or the weather conditions or the road quality. In this case, we're just comparing two trips. And what you're seeing here from left to right is from start to finish, both the speed at the top and then the acceleration at the bottom, obviously measured in speed per kilometers per hour and kilometers per hour squared. And what it shows that you have a red and a blue line. And why are they different in terms of what you're seeing here, that the consumption varied between 26.2 and 28.8. There is actually between the two, although the blue one is lower, it was actually carrying a higher weight. So you have to make that adjustment. And then for acceleration and speed, you can calculate these and therefore understand the underlying impact of acceleration and speed and therefore driver behavior on fuel consumption. You can't do this in Excel. You can't even do this in SQL. You need clever people with lots of Python knowledge to actually build this data science behind both comparative and first principle baselines. But it's really cool when you get it, and you can actually start working on that to be able to monitor against it. Then some additional points around fuel is around fuel price, because it's not only about how much fuel you use, but it's also about where you buy it and what you pay for. Firstly, there's an opportunity for network design and a national fleet operation with thousands of vehicles. You need to know where you should have bulk depots and where you should be buying fuel for those depots and how much you would use. Now, that's not new as an exercise, exactly the same exercise that you do for determining where to build your factories and where to build your warehouses. But the beauty of digitalization is that you can actually very easily get the data. Also need to consider to what extent you can use on-road fill. So rather than using only a bulk depot, which obviously is comes at a lower price, and we've actually been doing some, and the name that was given to this little bit of math is called the scavenger algorithm. It actually looks at where you have filled up and whether you could have filled up with less on road. Because if you think about, for instance, and that relates to zone pricing, the next point, but if you're driving from Johannesburg to Durban, you only want to put enough fuel in Johannesburg or in Pretoria to get to Durban, because fuel is cheaper in Durban. But you then have to scavenge through all the data to effectively find what you could have done differently to set new rules for business about how much you fill where. And again, if you run an operation with 50 trucks, you probably know all of this. But if you have 5,000, you have to do this with some data science. Already mentioned zone pricing. The reality is, you all know that from your own personal experience. Fuel costs less close to the coast, and we have to take that into account. There's also the issue of month-end inventory. How do you manage that inventory, considering that there are price changes either up or down? Not giving away any secrets, but that's pretty obvious. And then lastly, sourcing. So if you understand where you need what fuel, and you can easily quantify that by using this big data, you can apply that to determine optimal sourcing strategy from multiple vendors, or even, considering broader things like relationships around reciprocal business, etc. So fuel, biggest cost, and there's some really smart stuff around vehicles becoming more and more clever, telematics being out there, and then some really cool data science behind this. Then the next area, unlocking value for people and planet. And this is not from the people and planet, but essentially just a few ideas here. It is critical for us to improve safety. One of the biggest shortcomings of the world of logistics, transportation, is that there are lots of externalities. There are lots of people dying on our roads, and lots of people are affected also by our logistics transportation. We do, as a matter of course, record all incidents, and we make it easier to review them to understand what has happened so that we can learn from it. And if you have, again, lots of camera feeds, not only in cab, but around the cab, you can start using digital tools to do more than that, than just only trying to explain what happened. You have to consider driving conditions and driver fatigue. And again, you can only do driver fatigue essentially if you link that up with other systems. But importantly is that you can also then get into learning or training or education, where we can educate people around how to avoid accidents, how to minimize fatigue, and actually make sure that we end up losing less lives. Driver behavior. Again, this is not foreign to the things we live in our lives every day. We use my personal capacity or family capacity, use a very well-known insurance company, and I'm very happy to every month give the fuel rewards back to our children because it's they that drove better and therefore deserve to get the incentive. But what is possible with big data, with telematics, with digital, is that we can objectively measure driver behavior. We can measure it from the vehicle, from the telematics, and we can actually then understand to what extent there's been, and this is not new. So the point again here is to be able to measure harsh braking, harsh turning. The data is all out there. It's about bringing the data together and doing something with it. Gamification and rewards, the point around personal insurance, the same applies here. So how do you actually make it attractive for drivers to want to do better, and that they actually see part of that, and gamification as a concept in terms of how do you want them to see this as a positive and therefore reward them is critical to change or unlock value. And again, you can do that very easily through apps, combining information. So there's also the point of sanction. The reality is this is not just a carrot, and there is a stick required, unfortunately, also with people either themselves breaking the rules or with operations in terms of, for instance, allowable overtime and things like that, that you have to be able to use digital and data also to sanction driver behavior. Fuel consumption, I've already spoken about that as a cost, but from a planet point of view, to be able to become more green clearly means that we have to use less diesel or less petrol. The challenge is that it's actually quite difficult to quantify the business case. And through digital, because we have a really good understanding of not only the fuel consumption, but also the activity that took place. How many kilometers were traveled? How many of those were empty kilometers? How many of those were at what speed, and linking that to fuel consumption? We can actually understand what are the variables for consumption and how could we actively change the carbon footprint, obviously in parallel to the fact that we also want to reduce the cost. So making it much more scientific to be able to report on carbon footprint. There are also other technology alternatives, and digital allows us to evaluate them better, and to, whether that's at vehicle, but what would be the true carbon footprint or the true, if we have better data. There's an enterprise development, specifically in South Africa, great opportunities through better enablement of digitalization, actually to build the transportation sector through more smaller players. So it removes some barriers of doing business, and therefore we really think that a more digital fleet operation allows us to participation in all of these things around people and planet, or specifically planet, underpins the environment, safety and governance, and that becoming so much more important for any business, especially so for listed businesses. We have to use digital to run better business, but also deal with these specific aspects, reputation and responsibility of business. But it is important to close off this page by actually referring again to optimizing. At the end of the day, people and planet issues is critical, but we also have to consider, like with fuel, how we manage, for instance, driver cost. So this is not just about keeping people happy and motivated. Also, the simple realities, sequencing of logistics operations would be when the driver arrives for work, when he's briefed, when he's actually driving, when he arrives, when he's debriefed, and when he goes off shift. Again, that happens out there in many places. So it's not in a factory. And we can optimize operating costs by creating visibility of the activities in this environment. All right, then getting to pricing. If I recall, that was the last one that I want to talk about. And that is one, again, that we can apply to our personal lives. I would have loved to be able to actually use this Uber request this morning. Would have meant that I was actually going from the Cape Town International Airport to the Century City Conference Center, and it's a real pity that I have to do this talking to myself in my study. But the point here is that digital freight exchanges, and just read Uber, because that is the ultimate, provides both price and service transparency. So what they do is they make it possible for us to understand what it will cost. So you see the options. I need to decide, is it worth the premium to avoid getting a clapped out car from an UberX perspective, or am I rather going to pay for Uber Black? So I can get price sensitivity, but I can also get service transparency, because I can see where the vehicle is. I get annoyed if it takes longer than he said he's going to take, and I have the ability to rate the driver and the vehicle and everything else. So that we understand this world is that digital freight exchanges, a la Uber, does that for personal transportation. The question is, can we do this in the world of freight? And I think the first thing that we need to understand when we apply the DFEs or Uber logic to transportation is that you have to understand the difference between spot and contract. So if you just go onto an app today and you ask for, is there a truck available and what will it cost me to get from Durban? That is a spot transaction. You would suspect that if I want to contract that for the next year, that because I'm guaranteeing that I'll have a truckload once a week, I should get it for much cheaper. Now, that logic doesn't apply, because with contracted pricing comes a service guarantee. So you have to understand, how does pricing change over time? How does availability change? And what digital allows us is to understand, because of many, many transactions, if we use a digital freight exchange for freight, so not for people like in Uber's case, is we can actually understand how the supply-demand dynamics changes over time. We understand how service expectations change, and we can actually create a proxy using the digital tool sets and the data to understand what would be the right approach towards, or the right blend between contracted guaranteed availability versus spot, which takes into account the opportunities for lower cost in the short term. We also think that, and we're seeing that DFEs creates an opportunity to price for efficiency. Now, what that means is almost, and I'll get to that penalties a bit later, but the point here is that the current pricing for transportation is based on almost averaging or general rules where there's not specific provision for efficiency or then inefficiency. So typically waiting times or turnaround times or times of operation. So if you could use a digital freight exchange to actually guarantee that you pay, that you will be, you can charge less for a shipper, so somebody with product, if he turns the vehicle around quicker. So then you price for that efficiency, and that's possible because we can actually understand, is there a true saving by using the vehicle for the next load? So there's a huge value unlock possible from pricing because you can actually link efficiency with pricing. Really, we should actually charge premiums or penalties for things like surges, load variances. Now, Uber does that, and we probably don't contest that. The simple reality is that that's not the case yet, and the point is that you should be able to charge that through smart contracts, blockchain, distributed ledger. But the reality is that that's not a digital challenge. It's actually about industry behavior, because it is accepted practice that the inefficiencies are not priced in, or they're not recovered if they happen outside. I thought this is a good place to actually add this bit of wisdom, which Lloyd referred to earlier as well in his talk. We must understand that the role of technology is actually not to disrupt. It's to make it possible for us to be more client-centric. And somebody had asked me I must include the source, and the only thing I could say is this is essentially sort of various social media sources that says that, and the examples we used earlier, I think Lloyd spoke about laziness when he spoke about Netflix, but this is also the annoyance of late fees. Uber, I don't know how many of you have been overcharged by a taxi. That problem has gone away. And if we look at using Uber or digital freight exchanges in the world of transportation logistics, we also need to make sure that we're doing that, because it's actually about serving the client and translating the service into the right price for the client to pay. Last slide, essentially, very busy slide, and the purpose of this is not to try to explain all of this, but what you'll see in the big diamonds is the big digital enablers: Internet of Things, smart machines, cloud computing, analytics, etc., AI, ML, DFEs, and then very importantly, fourth industrial revolution. These are the things that we have available that will help us to unlock value. In the small little diamonds, it's the tool sets we use, whether that's telematics or driver tags as IoT devices, or fuel transactions and time and attendance that allows us to do big data. The world of data engineering and data science that allows us to build smart baselines and analyze, diagnose, and visualize. Control towers, the supply and demand matching in an Uber environment through digital freight exchanges, pricing strategy. And then very importantly, all of this comes together through the integration of these digital tool sets. So the conclusion must be that we unlock value in the world of logistics or transportation because we understand what value is. We understand how we can unlock value by doing some pretty boring things like recording service, and do some pretty sophisticated things like setting up smart baselines for fuel consumption, or even managing pricing on a dynamic basis. But all of that ends up allowing us to actually improve the benefits to the planet, to people, and to business and profits. And I'll close with putting that picture up again, just showing how much is changing in the world of lots of things actually becoming fairly obvious, even more things coming down the line. Great opportunities to do lots of things very differently and improve value across the spectrum. Thank you very much. Left a few minutes for questions. Happy to take that, or comments. Not sure I'll stop doing this.
Cobus, if you open up your discussion tab, if there are any questions, they should be visible there.
Some people didn't hear much of what Yeah, Colin, I'm not seeing many questions. Happy to take some if there are.
We'll just give people a few minutes to think about it. If there's anything they'd like to ask, we do have a few minutes. I'm not seeing it, Cobus, so I'm going to thank you very much for a... Oh, I just got a message to say there are questions. Let's have another look. Q&A. Okay, there's Cobus. If you just have a look under Q&A, you'll see there is a question there from Henry Perry.
Okay, the question is, may you please come again on reducing waiting time? I think the point I'm making is that waiting time is the waste in the system. So if you think about a factory, there's lots of, and there's obviously a science around waste management and Six Sigma. But if we understand that that is waste, because if a truck is standing still, it is not it's not earning revenue. And if you think about how we apply waste management strategies in a factory environment, it's all the logic around recording it, understanding its underlying causes, etc. I'm not the expert, but if you can do the same with waiting times, but the problem is waiting times happen out there. You don't see it happening. So the point is, if we use digital to understand exactly where the vehicle is waiting and how long it's waiting and what it's doing while it's waiting. I never mentioned that. But for instance, if it's idling while it's waiting, that's hugely wasteful. Or is it waiting because it's out of service and therefore it's okay because it's not being used in a night shift because it's a day shift operation? Or it's waiting because it is in a workshop. It must be maintained. I think the point here is that is the waste of a transportation logistics operation. And if we know what it is, where it is, how much it happens, you can do something about it. Now, take that one that is slightly controversial, but if you find out that you are spending lots of time waiting at a customer site or at a client site, you could ask yourself, well, is that happening because you arrive early? Then that's not really the client's problem, is it? Or is it because you've arrived at the agreed time, but then, something happens and therefore, you're just not allowed to offload your vehicle? Or is it happening because you got there on time and the client was ready for you, but for some other reason, the driver actually didn't take his opportunity in the queue? Because maybe there's a perverse incentive for him or her not to finish their work because they get overtime if they arrive back later. Now, if you think about how we do that in factories, we have deep visibility of exactly when machines stop or when they use more material, that's the fuel example, than they should have. And that's around how do we're reducing waiting time, in my view on this example, by understanding what it is, where it happens, and why it happens. But you then have to, at scale, be able to use data. So you have to be able to say waiting at a red traffic light is not waiting. Now, unless you get really clever like the FedExes or UPS of the world and only turn right and miss, all the red traffic lights. But that's not quite where we are. So I think that my point is, it seems so obvious, but we don't necessarily do it in such a scientific way. So that's my argument, that we can apply what we've known about factories, what we've known about warehouses, but we apply it in the world of transportation, and that digital makes it visible, possible, and not easy, but at least it can be done. And it's
there's another question. If you look on discussion under audience, you'll find there's a question at the bottom there.
So the question is, do you see, it's from Shamendra, which I think is from Dovetail, if I recognize the name. Do you see online brokers like linebooker.com become more prevalent in the near future? So Linebooker is to date South Africa's most successful, I think, digital freight exchange. So they, in terms of what I said around pricing behavior, pricing structure, they have a key role to play. There are obviously other players that use digital sourcing tools, etc. And the answer is absolutely yes. So life must become easier than it's been in the past. And what online brokers or digital freight exchanges, I think they would rather be called the DFE, what they do is they create the ability to actually explore sense pricing. So because people digitally engage and say, I have a load and I have a capacity, bring them together in some way. And it must be easier to do business digitally, and they will play a bigger role. The biggest challenge is how do you link reliability with that? So at this stage, there's worldwide, it's still a challenge on to what extent can you guarantee a service through a digital freight exchange rather than through involvement with sort of what you call traditional line haul providers.
Okay, well, I think our time is up now, Cobus. Thank you very much for a fascinating presentation. which gives us a real insight into what happens behind the scenes in the big organizations, the big 3PLs. So once again, thanks very much. To the audience, I'd like to remind you, please complete the poll. If you just look on the right-hand side of your screen, there's a little tab marked polls. Just click it and give a rating as to what you thought of this presentation. Thank you very much, and see you at the next one.
Cool. Thank you very much.